Molar mass. Molar mass is equal to molecular weight in grams. And what that means is we're going to add up, and I'm going to show you how. We're going to add on the molecular weight in a molecule. And if a molecule has multiple atoms in it, we'll add up atom by atom by atom. Okay? It's really simple. I'll explain, I'll show you how. I'm going to need a periodic table for this one. I wish they would give it one on the wall. That would make too much sense. All right. I'll get to finish grading your test. I'm almost there. Grade record PS test. Let me add that, okay? Raise your cyber hands if you're ready. You have this written down. We're going to show you a lot of formulas. We're going to show you a lot of ways to do these problems, but you have to be sharp. You got to be awake, and you got to write down everything I write down. I don't care if you start, oh, I get it. Write down everything I write down. Practice problems, everything from this point on, okay? This is important. Molar mass is equal to molecular weight in grams. Atom plus atom plus atom, right? Raise your cyber hands when you are ready to move and you've written this down. Turn off the games, unplug yourself from music. This is the high school part of the course. That's an R, by the way. If I write fast, it looks like a K. I'm sorry. Molar mass. Raise your cyber hands when you're ready. I don't want to leave anybody behind. If a person isn't ready and they don't have a formula written down, oh boy. It's bad. I'm not going to move until everybody is ready. Molar mass equals molecular weight in grams. Ashley, are you ready? Cyrus, are you ready? You ready? Okay. Now, you never leave a man behind. All right. If a person just doesn't understand moles from the start, oh boy, it's bad. Okay. Next thing, moles are equal to molar mass over what we call given grams. And I'm going to start the problems in just a second. Moles are equal to molar mass, and I'm going to show you what that is, over given grams. Molar mass is molecular weight, but I'm going to show you. Moles is equal to molar mass over, meaning divided by, the given grams. This will be the grams given in that were weighed out in the lab. Molar mass, I'm going to show you exactly what they are. This is really, really easy and fun. But one way you can calculate the number of moles in something is molar mass divided by given grams. You all know what significant figures are? You ever heard of that term, significant figures or significant digits? All right, I'm going to teach y'all. I shall be the first. Significant digits. Okay. Cyber hands, who's not ready? Who needs more time? You're all ready to go. You have this down. All right. Let's do a problem. Let's look at a problem. Okay. I have, there it is. 25 grams. 25, I'm going to write a little, that's a G. Okay, 25 grams. Mass, weighted on a balance, a digital balance. I have 25 grams of potassium permanganate. KMnO4. Okay? Let's find its molar mass. Molar mass is equal to the weight in AMUs in each one of these all added together. Well, I have potassium, 39.1. I have one potassium, all right, 39.1 plus. I see some, what is that, manganese? Yeah, manganese, it weighs 54. Now make sure you're looking at, you're using the molar, we're using mass, not the ones that we want the ones with the decimals, okay? 54.9. It's okay to use the decimals on this one. 54.9. And then we have 4 oxygens. We have 4 oxygens. So 4 times 16, okay? 4 times 16. All right? Add those all up. Let's see what you get. I'm going to make a mistake in my addition. I do go too fast. So I'm going to actually bring up my calculator just to make certain. 39.1 plus 54.9. 4 times 16. I'll do that first. Plus 54.9 plus 39.1. I get an answer of 158. And it's like, okay, moles, Mr. Saban, what is it? Nope. This is molar mass. Mass is measured in grams. I know it's weird. 158 grams. I say, whoa. Hold on here. He was just talking about how, the guy was just talking about how tiny these little atoms and particles are. Wait a minute. 158 grams, this is the molar mass. You'll see. I'll show you in a second. We take each one of these. There's potassium, there's the manganese, there's the oxygen, see? We add them all up. This is the molar mass. It's also called the molecular mass. It's the same thing, molecular mass. Take your time. Take your time, write it down. Raise your cyber hands when you're ready.
Why wouldn't it be 158 AMU?
Hang on. Gotta get my ears in. Say it again. Why wouldn't it be AMU?
Yeah.
Okay, wait a minute.
Isn't that what it is on the periodic table?
Play back, because this is the mole. Here you go. I'm gonna disable that. Now I can hear you better. This is the mole. You gotta follow me on this. 158 grams. And we're gonna use this.
But what is the significance of, like, why are we doing grams?
You'll see. Wait. I need cyber hands up before I go to the next one. Who's ready to go on? Who has this written down? You're going to be doing molar mass for weeks and weeks and weeks and weeks and weeks, and it's really easy. It's the fun part of figuring something out. Okay, I'm waiting on 1, 2, 3, and 4 people. Marusha, you ready? Cyrus, you ready? Michelle, you ready? Okay, don't leave me hanging. Michelle, are you ready? Maybe you can't raise your cyber hand. Sometimes that's the thing with Zoom. I don't know. All right, well, if you need more time, let me know. So, there we go. Next formula, and then we're going to do a problem. Converting moles to physical grams. Moles of material over 1. This is what we're going to call the canceling method. Moles over grams over 1. Just trust me on this. Moles of material could be atoms, could be donuts, could be particles, molecules. It doesn't matter. Moles of material over 1 times molar mass, that thing we just learned, over 1 mole of material. Write this down. This is how you're going to justify your answer. And you're going to be doing this all the way through, even if you don't major in chemistry, when you go to university. And even if you major in music, basket weaving, genetics, you're going to take a chemistry class freshman or sophomore year. And they're going to ask you to do this. Can't hear a word you're saying. What? What does it say under mole? What does it say under mole? Moles of material over 1 times molar mass, 1 mole of material. You're going to see why I put it there. It's up here and it's down here. 1 mole of material. 1 mole of material. Okay? 1 mole of material. This is how you're going to justify conversions in high school, college, because when you line it up properly, moles of material here, we're going to cancel this unit out with this mole of material here. If I have moles here, I'm going to be able to cancel these out, leaving only molar mass, okay, or moles, okay? Now you're going to see in a problem, we're going to do lots of problems. But this lining it up, setting it up like this is how you are going to justify. Raise your cyber hands when you have this little leaflet. That's 1 mole of material. The reason why I have the lines here, you're going to see in a second, because we're going to cancel these 2 out, leaving only molar mass or moles. Right. No one has written it. 4 people, 5 people, 6, thank you. 1, 2, 3, 4, 5, 6, 7, 8. I have 9 out of 13.
The 1 mole material cancel each other out.
You're gonna see. You're gonna see. All right, I think we have everybody. All right, so let's do a problem. That's 1, that's 2, that's 3. All right. In a problem, I give you 25 grams, like I said, of KMnO4, potassium permanganate. I give you 25 grams of it. We measure it out in the lab, not 25 moles, 25 grams, okay? We worked out the molar weight a couple of minutes ago. What was the molar weight? You remember? There's a 39.1 plus a 54 was 158 grams? Yes, that's a G, grams, because we're going to convert this to moles. So what we're going to do, we take the 25 grams, okay, we take the 25 grams over 1. Actually, not over 1, it's 25 grams. This is easy. Yeah, this is the easy part. This is super easy. Because remember, moles, if we're going to take grams, and this one, this is grams to moles. Your first grams to moles problem. 25 grams, we divide it by the molar weight of 158 grams. Well, these are going to cancel, and this is going to leave us with 0.158 moles. There's your answer. I'm just holding your hand on this one. 25 by 158. Now, here's where this thing called significant digits comes in. If you used a calculator, the calculator answer for me is 0.15822784881. Okay. Significant digits. Might as well start with this. Significant digits. Well, here, let me raise it up. Okay. The calculator says this. I'm going to change this answer to make it the correct number of significant digits, because a calculator can generate an answer that large, all right? It doesn't mean it's accurate. I'm going to be your first little introduction to significant digits. Look at all of the numbers used in your calculations. In science, look at all the numbers used in your calculations. I see 25, I see 158. That's not a 0, that's an O. You find the smallest, the value that has the smallest number of significant digits. 158 has how many digits? 3 digits. 25 has how many digits? 2. This is the lowest number of significant digits that have been used in the calculations. 2. Therefore, the answer cannot have more than 2 significant digits. So here is my answer, 158, I round. I change 158 to 0.16. This 0 here is a placeholder. This is a significant digit, and we're going to learn this over and over and over again. This is a significant digit. There's only 2 significant digits. The calculator gives me this. But we know that the final answer cannot be more accurate than the smallest input. So therefore, the most accurate of this answer, it can only have 2 significant digits. So we round it. We convert this huge, well, it's not a huge number. It's a long number. It's not a huge number. We convert this into 0.16. We round this up, that 5 up to a 6, and that's it. Let me teach you something here. If I wrote it as 0.160, how many significant digits are in this number? This 0 is a placeholder, doesn't count. This one is a number. It's a non-zero number. It's a non-zero number. This one, it counts. It's a non-zero number. This one here, well, it's a 0 number, Mr. Saban. If it's a 0 number on the end, this would be considered significant. If I had like a laser rangefinder and I measured the distance to 0, you know, like, I don't know, 0.16000 of a meter, if it's that accurate, holy cow, I mean, that's, wow, that's very, very precise. But the number that set this up is 2 significant digits long. The final answer cannot be more significant than the least number of significant digits in the input. So it's 0.16. Once again, that doesn't count, that counts, that counts. Let me ask you something. And this is your first introduction to significant figures. The number 108.010. How many significant digits in this number? 1 is a non-zero number, 8 is a non-zero number, 1 is a non-zero number. What about these? Okay. If the 0 is between 2 non-zero numbers, significant. Here's a 0 between 2 non-zero numbers, significant. Stupid French lead. Here's a 0 over here. Remember the laser rangefinder? If it's over here and it came spitting out, I have to question if this one is significant or not. Let's say in order to get this number in my computations, wow, I used a device that is, here, there's a 1 here. I used a device and I used that is, 4 significant digits before. 4. I have 1, 2, 3, 4, 5, 6 here. That's a 1, remember. 1, 2, 3, 4, 5, 6. This cannot be more accurate than 4 significant digits. So which ones do I keep? Well, I keep the 1, I keep the 0, I keep the 8, because I have to go left to right. 108 point, I have to keep that 0. 1, 2, 3, 4 significant digits. Okay? But I have to disregard, I got to disregard this. That can't count. As we do these problems, you're going to learn how much to round your answer down. I promise. Let's do another problem. Okay? Questions so far? But we're going to learn by doing. That's chemistry. I'm telling you, folks.
So is grams to mole given grams divided by molar mass?
It is that moles is equal, okay? So going from grams to moles, I want the moles. I take the molar mass in grams, divided by, and this is the molar mass in grams, divided by the given grams, the big 25. You'll see. Let's do another one.
Wait, so like the molar
You're
mass.
echoing.
Wait, so the molar mass over the given grams is
The moles. Yes, molar mass over given grams is moles. Yeah,
so it would just be translation from grams to moles.
that's right. You just converted from grams to moles. That's the whole idea. How many moles? It sounds so goofy. How many moles in 458 grams of, oh gosh, Na2SO4? First thing here, I have to find the molar mass. Well, here, moles. Remember, moles is equal to molar mass, and that's that whole atomic thing where I use the periodic table. Molar mass over given grams. Well, there's the given grams. I have to find the molar mass. Do that now. Watch me if you don't know how. You guys write this down. I'm going to get started here. Here, I'll move this off the side. This lead is awful. This graphite. Ugh. 2 times. Okay. S equals 1 times. O equals 4 times. Okay. I hear somebody thinking, breathing. Yeah. It's Na2SO4. Let's find the molar mass. Na equals 2. Here's the Na here. Mute yourself. Na is 2 times 23. Sulfur, 32.1. I only have 1. Oxygen is 16. Multiply, let's add it all up. Let's do the totals. Ugh. 142.1. It's not just the mask and the fogging up the glasses. This has to suck too, you know? Notice it's a 2 because it was a 2. How many of you got 142.1 for molar mass? It's not the final answer because moles equals molar mass over given grams. So we just figure out what molar mass is.
I got something similar, but I used a different periodic table. So
Okay, I understand. I got you. This is why we standardize all the tables. Yeah, I understand. Totally fine. So in this case, moles, we're trying to find for moles, will be equal to the 142.1, technically that's grams, over the given grams. Well, piece of paper. There it is. The given grams, 458 molar mass over 458. No, I don't even have to put a 0 on it. Just divide it out. 142.1 divided by 458. I get an answer. I get a calculator answer. Calculator answer. Oh, geez. 0.31026. Blah, 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 blah. Okay. Look back at our the number used in our calculations with the least amount of significant digits. That means we can look at our calculations here, using, in order to find molar mass. We can look at the original problem. Which one has the smallest number of significant digits? I see technically 1, 2. I don't know about that 0. 1, 2, 3, 1, 2, 3, possibly. I don't know about that 0 either. I see 1, 2, but this was calculated as sodium. It's 23.0 at least. I put 0.00. How many sig figs do you think we should calculate this thing to? You want to play it safe and say 3?
Yeah.
Okay. So let's cut this off. 0.310262. All right, the answer is 0.310. There's your answer, but wait, what units?
Moles.
Moles. 0.310 moles. All right. Converting grams in the lab into this really goofy unit called moles. Let's do the other way around. Let's go moles to grams. Moles to grams. Sounds like graham crackers. All right. You have 4 moles. 4 moles of carbon. How about that? 4 moles of carbon. How many grams in mass, will that be? Because moles is such a, it's a strange number. Moles to grams, okay? You have 4 moles of carbon. How many grams will that be? Write that down. It's a snail's pace. If we don't, oh boy, it's gonna hurt later, okay? There's nothing worse when somebody comes back online, in terms of thinking, because the test or the quiz is coming up and they didn't listen in the beginning and they didn't get the notes in the beginning and they get the new stuff, but the simple, more easy stuff, the fundamental stuff, oh God, they didn't get. So this is right here. This is 21 years of teaching it, okay? All right. You have this down, moles to grams. You have 4 moles of carbon. How many grams will that be? Did everybody have that down? Who needs more time? Take your time. If you need more time, do not be ashamed to tell me. Okay. So you have that written down. Keep looking at that. Let's do some conversions, okay? Remember we were looking at this thing, moles to grams? Moles of material over 1 times moles of mass over 1, okay? We've already written that down. Let's use it, okay? 4 moles. I'm just going to write 4 moles C, 4 moles of carbon. Put that over 1 times. Remember, the goal is to go to grams. Molar mass. Remember, mass is always in grams. Put it in parentheses. Grams, it's grams. Over 1 mole of carbon. I'm going to write out the carbon. And let's finish it. Is equal to grams. Mole of carbon. Wow. Mole of carbon. Cancel that. Cancel it out. What's the only unit that's left? Mass in grams. All right. So what is the mass of 1 mole of carbon? $12. That's what molar mass is, right? See, I don't have to add anything up. I can just look this thing up. continuing on, 4 times, and you could use the little multiplier symbol, the dot, I don't care. I mean, I don't care. 4 times, it's not 4x, it's 4 times, okay? 12, now my periodic table says 12.0. When I went to high school, it was 12.01, but this is fine. That's it. 4 times 12.0 is 48. 48 what? Grams. Little g. 48 grams. That's it. That's it. We canceled these units out. By writing this, I know it's like, why don't we just write it shorthand like this? Well, if I just wrote 4 times 12, I get partial credit. I wouldn't get all the credit. You got to show that you're canceling out the units. Get in this habit. In high school, they taught us to do the shorthand way. I got the University of Dayton, and all of a sudden, oh, they want us to write it this whole way. All the other kids around me, they just instantly know how to do it. I had to relearn this stupid thing. It just slowed me down. Okay. They want to justify your answer. So you just, you show it here, you divide it, this divided by, it cancels out. It means it's 1. Okay. But it shows your lab assistant, your professor, your teacher, your chem guy, that you know what you're doing. You're converting. Get used to this conversion and showing your units. Okay. All right. Let's do another one. I mean, am I clear to go? Okay.
I just don't get how like you go like the molecular weight. Like how do you get to grams?
Because all of these masses, hon, are already calculated to be molar compatibility. They're molar compatible already. They really thought it out.
Aren't the weights in AMU?
That's right. And AMU is in molar mass in grams. Let's do moles to grams. Let's do another moles to grams. Moles to grams. See, the AMU is actually the molar mass. They didn't teach you this stuff in 7th grade, see. 5 moles of oxygen, 5 moles of oxygen. It's one of those diatomic little jerks, isn't it? 5 moles of oxygen to grams. Okay. Well, I know it's going to be, how to do this. It's the moles of O2, moles of O2 over 1 times molar mass, right? Molar mass. And this is going to be over 1 mole, so that we can cancel those out, and those only leave, this mass thing, and it's in grams, right? But we have to calculate that molar mass thing. So this one always throws young students because they've been working on balancing stuff, and then we switch over to this, and they forget, that oxygen thing is diatomic. They just say, it's oxygen. Well, they're just jerks. They're people, these old people who give us these problems, they're just jerks. It's O and 2. So molar mass is, because the mass of oxygen is what? 16. 2 times 16. Well, that is 32, right? So let's do this prim and proper. Moles of O2 over 1 times. Here's our molecular mass. There's the 32. And I know it bothers you. 32 gram. Yes, 32 molar mass. Molar mass is in grams. It's crazy, I know. It's molar mass is AMUs over 1 mole. Cancel this out, leaving only 32, of course. How many moles? How many moles did they give us? 5. 5 moles of the oxygen, right? 5. 5 times the 32. I've got 160. Oh boy. 160. How many significant digits is this? Well, you have to think of this as a decimal sort of hidden here. So it's 1, 2, 3 significant digits. Technically, it's a hidden decimal. Okay. You treat the decimal as like a non-zero number. Okay. And don't worry about significant digits right now. I'm going to teach you. How many significant digits are in the input to get the answer? Look at this. This is the lowest one. This is the lowest significant, I use the 5 in order to get the answer. There's the 5 times of this. Can I convert 160 to one significant digit? Yes, I can.
No.
Yes, I can. I know it's crazy. For now, folks, for right now, if you write 160, now what's the unit?
Grams.
Grams, good. If you were to write, for the moment, 160 grams, you totally would have gotten the right answer. I would have given it to you because you're still learning significant digits, okay? How do I take 160 and change it and round this into a number of the correct number of significant digits? Well, it has to be rounded to 5, right? Technically, what you would do, this is where it gets tricky. You would say, because it had to be 160 grams, I have to round this to a number that's one significant digit. That means I have to round up that one. I would say 200. And this here and this here don't count. But 160 grams for right now is A-OK perfect. Okay? I'm surprised I haven't taught you significant digits in math yet. Okay. This is perfectly fine. 160 grams, totally acceptable right now. Okay? All right. Let's do another one. Let's do one more, and we'll close it out, okay? One more. Questions, anything about this? Right now, it's just, hey, we're lining up fractions and we're canceling stuff, and it seems like it's a really difficult, super complex way to do something really stupid and just multiply. Yeah, you'll see. Let's do another one. Let's do another moles to grams. I'm going to ask you how many grams in, oh boy, 2.3 times 10 to the 24. Ooh, we're going to go atoms. We're going to get a little tricky here. Atoms of silver. It's like, what? How many grams in this many atoms? Write this down. You guys write that down, and we're gonna start there tomorrow. You gotta trust me on some of these. You gotta trust me. I'm gonna take your hand, we're gonna go through these slowly. That one down. Here it is. Most grams per gram. Okay. Uh, 2.3 times 10 to 24 atoms of silver. Okay. I'm not that way. We'll start tomorrow. This is number 3. Stupid lead. Actually, it's graphite. Raise your cyber hand when you have this one down, please. My ears are out right now, so I can't hear you if you're talking. Give me a second. With masks and water and echoes and earpieces, and it's like extended sea diving just to teach moles. Okay, well, we'll check your answer tomorrow, next time on Dragon Ball Z. Anybody have any questions or need to see anything else? that we've done so far today? Any particular formulas? Molar mass equals molecular weight in grams. Old problems. Moles to grams. How to calculate molar mass. Anything. All right. Grams to moles. Moles equals molar mass divided by given grams. Okay. I have this hunger for golden grams now. All right. This is where we begin. Tomorrow. Everybody's got this? Okay. See you tomorrow. The rain starts tonight, and the rain will not end until Friday, apparently. This will be interesting. You might need a canoe if you're traveling anywhere. See you later.